So we started at least this portion of the demonstration. We started by saying, if we find it useful to have these concepts, circle, square, and rectangle, and then we went ahead and created like a formal design for it, right? We decided, oh, let's start with square and a circle. Let's start with square. What should we be able to do with the square? Oh, we can like remember the side and be able to draw, right? A circle should remember the radius and be able to draw. Okay, we went ahead and created the corresponding classes. A circle originally had a constructor which initializes the radius. The square had a square constructor which initializes the side that it maintains. Then we added the draw method, which is kind of ridiculous in our case. We just print something on the console screen, but it's perfectly fine to test and verify if all concepts are in place, if the syntax is correct, without actually messing with any sort of drawing, right? So we added these two. Where are they? Right here, square and circle. So then we decided to say, oh, we also want a rectangle. Well, I said, I kind of was unsure about it, but decided that maybe rectangle should be deriving from square, and I did that, and somehow twisted everything and made it work. So I used this curious superclass constructor call, which we will discuss next week. So, but intuitively, I hope you understand that what happens is that, especially I was capable of demonstrating it on this, sketch, that when a rectangle is created, because it extends square, rectangle is a square by definition. Therefore, when I try to picture its box, the box that in memory represents the space occupied by the rectangle, it encapsulates inside another box which is a square, okay? Because, by design we said, in our case, rectangle extends square, which in terms of design language says rectangle is the generalization of square, right? Or actually vice versa. Square is more abstract, rectangle is more concrete. Rectangle is a square. And then it adds its own little piece, side 2, to the imprint in memory. And that is here. So it has its own constructor, but it also has a draw. And then we had to add get side to the design of the square class, because side is private, but a derived object needed access to the side, and we said, okay, we'll give you the get side method, so you can actually make a call and get that value from the base class, from the superclass. So then we said, okay, let's do all this and test individual objects. We were able to do that, and we were able to draw them. Then we said this is good, but not good enough, because what we want to have is some sort of a collection of shapes, so that once created right here, in my case this is Java array, an array of shapes, and there are like 3 of them are created. And so they're populated somewhere here in memory, in its own spot, taking away resources. Initially, this shape array contains no real references to any objects. It's just, it gets created and it gets initialized internally with all zeros, so that we're in a known state to begin with our array. In fact, if we would have created an array with like 1 million shapes, it could have taken some time to initialize million locations of these references with 0. There could be some waiting time on that thing. You may experiment it on your own. So anyway, but to begin with, it points to no objects. But then we say, hey, listen, we can create brand new circle, we can reuse already existing square, we can grab a rectangle and store these references in this array. And then we can actually, intentionally, we forget the type of shape that is being referenced inside the array. And then we just say, we can then even go as far as ask the user, so what element would you like us to draw, right? We could have let them know, okay, the range, the legal range of these references is from 0 to 2, 0, 1, and 2. And then we go ahead and do our drawing, right? Just saying draw, right? And that prints something on the screen which represents, imaginary object being drawn on some sort of a 2D plane, I suppose. So this is a series of manipulations that I did in the code, and also kept the design for it in my mind to sort of achieve this result. Now, of course, I could also create a loop and draw all of the shapes, right? So, in fact, this is very simple. I can quickly do this as just to show you the kind of like the proof of concept. For example, a for loop could use an index that starts with 0, and then index should stay within the bounds of shapes, the length of the array, and then I can increment index on each iteration, and within each iteration of this loop I can say the same thing, shapes draw. So this small loop, so this small loop actually will draw all of the shapes. So just another demo that I can just go ahead and draw all of them, right? So I can which element to draw. Okay, let's draw element number 2, right? So it gets drawn, but then we go ahead and draw all 3 of them in that loop. Okay, just another little demonstration. What we just experienced was polymorphic behavior. Polymorphism stands for uniform interface. In our case, in our demonstration, uniform interface was here. Shape gave us uniform interface. We then took advantage of having this uniform interface and created an array of this type. This shape type was used to create an array of shapes right here. In fact, the array had 3 elements. That was our decision. This is, by the way, another inflexible part. We could have asked the user, well, how many shapes do you want, right? And instead of hard-coded 3, we could say whatever the user entered, right? So then, now to be able to take advantage of this, the idea of polymorphism, is that we need to say that we have to have some derived classes from the base interface. Shape, rectangle, circle. Well, in our case, there was like a square in the middle of it. We had even more advanced design, because remember, the goal was to demonstrate that draw was defined for square, but then was redefined for the rectangle, which actually reuses some of the square features, but still is capable of add its own features, such as draw, to the entire application, right? So we had the inheritance in place, and I know we still have time, right? We're here till 1:45. Oh, perfect. That's perfect. We actually found some time. That's great, because we can talk about the homework. Okay, and then each derived class. In fact, the application will not compile unless each derived class, in our case, the derived classes were square, circle, rectangle, provide their own version of the promise given by shape. The shape said, we promise to whoever is going to use shape, in our case we use array of shapes, that they will all, whoever will implement shapes, they all will provide the draw method, which will be doing something concrete. And that's exactly what happened. If I took this out, the code will no longer compile. The compiler will say, okay, I mean, we have declared that each shape must provide draw, but you didn't provide it in one place or the other, and it's not going to work. So we do the second step, that we implement all the methods which were declared in a shape in our demo, and then uniform message like draw can be sent to an object. It will respond in its own distinct way. Right here, when I go to my main method and I create this loop and I say, for every single shape in this array right here, for every single shape from 0 to the length of the shape, go ahead and loop, increment index every time, so index goes 0, 1, 2 in our case. Go ahead and draw the shape. Well, guess what? According to this slide, it says uniform message is sent to each object, but it does respond in its own unique way, because look, circle says this, square says this, and rectangle says something else. They're all doing its own thing. However, look what we do in our code. We perfectly call the same method. In other words, send a message to an object saying, why don't you draw yourself right now? That's what we want you to do. But what the curious thing is that when we have this array of shapes, the messages are dispatched to each concrete object. If it's a circle, this draw is invoked. If it's a square, this draw works. And yet again, if it's a rectangle, this draw is executed, right? Whatever these classes provide in terms of the implementation for draw, that's exactly what happens.